Hi, my name is Ben Curry, and I'm going to be taking you through a rerun of the demo that we gave at DockerCon 2017. Now, the whole point of the demo was to showcase many of the technologies that we're working on at VMware, some of which are shipping products and some of which are speculative innovation. But the whole point of the demo was to illustrate this point that containers and VMs are complementary. Right? We believe that when it comes to business value, the combination of containers and VMs and being able to treat VMs and containers in similar ways are going to drive real value for our customers. So let's look briefly at the technologies we're going to be showcasing in the demo I'm about to give you. I would characterize them in two ways. We're bringing the best of Docker to vSphere, and we're bringing the best of vSphere to Docker. So what do I mean by that? Well, in terms of bringing the best of Docker to vSphere, we have vSphere integrated containers. Now, vSphere integrated containers is a Docker-compatible API on vSphere that allows you to control vSphere infrastructure from a Docker client. So when you do Docker Network LS, you see vSphere networks. When you do Docker Volume Create, you create a disk on a vSphere data store. And when you do Docker Run, you get a VM that has all the characteristics of a container and that is running a Docker image. That is vSphere Integrated Containers engine in a nutshell. Now, in the VIC product, we have two other components. Harbor is a container image registry, and container images are becoming more and more important to our customers, not least because with VIC, we can use the same images to provision VMs as we do to provision containers. So images are very important, and that's why we have Harbor. Admiral, on the other hand, is simply a management portal, a UI that ties all of this together. It shows you the images that you have the right to provision. It shows you the endpoints you can provision those images to and allows you to connect up the dots. So vSphere Integrated Containers really is about bringing the best of the Docker model, the Docker workflow, the operational efficiencies of containers to vSphere. Now, in terms of bringing the best of vSphere to Docker, we have a couple of Docker Engine plugins we want to show. So one we've been working on somewhat speculatively behind the scenes. This is a little bit of a sneak preview of an NSX libnetwork plugin for Docker Engine. And as you'll see, that allows you from Docker to create networks in NSXT, to connect containers to them. You'll see that in the demo. Now, the Docker Volume plugin we're going to be demonstrating is a very similar concept, but for storage. It allows you to create disks on vSphere data stores and mount them directly into Docker containers. Now, the Docker Volume plugin is available today, and you can go and download that as and when you wish. Now, Containerd is something we've been looking at. It's not going to be part of this demo, but we're contributing to Containerd, and we think there's a lot of value in that project. We've also been playing around with Moby. We have nothing to report on that yet. So ultimately, what we're doing here is we're changing the way that you can consume vSphere and creating the possibility for container workloads to consume vSphere infrastructure and work with vSphere infrastructure just like any other workloads. So, on to the demo. So, the first thing we're going to do is to create a virtual container host into the infrastructure that you see here. Now, a virtual container host is basically the means that a vSphere admin has to make available a certain amount of compute, networking, and storage to a tenant that they can then use for self-provisioning via a Docker client. Okay, so the admin needs to basically have a means of saying, okay, I'm going to pre-authorize you to a certain amount of compute and networking and storage and make that available. So let's go through the process of what that looks like. So here is the compute that we have. We have a cluster here called Minis, because it's a cluster of Mac Minis. We have 3 ESX hosts. In terms of storage, I have some iSCSI shared storage, which we're going to be using. Now, if we want to use DRS to provision and schedule our workloads, we need to have shared storage so that DRS, the storage is available on all of the nodes. And the same is true of networking as well. We have a distributed virtual switch, and we have 2 networks. External network, which is a port group that actually has DHCP and has public visibility. And then this devcert test, which is an ephemeral port group that is really just for internal communication between containers. Now, in terms of the users, if we go back to home here, go to administration, you'll see that I've created a T1 user that is going to be the proxy user used by this endpoint. So everything the tenant does via their Docker client, this user will do as a proxy in vSphere, and you'll see how we use that in a minute. So how do I express that I want to make this virtual container host available to a tenant? Well, there's a binary called Vic machine that ships with Vic engine, and you can see it here. We'll just run it. And Vic machine is about creating, deleting, managing the lifecycle of VCHs. If we type create -- help, you'll see that it takes a whole bunch of options. If we do create -x, you'll see there's even more options that we can specify, right? Which is a little overwhelming. So one of the cool hacks that we showed at DockerCon was how we can actually organize all that stuff into a single JSON manifest that we can then actually input into Docker itself to provision our virtual container hosts. Now, the hack, if you want to go and read up about it, it's in this repository here in GitHub. You go to Vic machine, it tells you all about it, all about how to use it, and I'm going to show you how that works. Now let's see what we have here first of all. We have definitions for 3 virtual container hosts. Now, VCH3 is the one we're interested in, so let's look at VCH3 and config.json. Now, this is all the same options that you just saw to Vic machine, but arranged in a way that's much, much more easy to consume. So you can see the VCH definition here, and we have compute, network, storage, and some other bits and pieces. So with compute, we specify the cluster, we specify memory and CPU limits for the client. In terms of networking, we specified that ephemeral port group as a bridge network for the containers to talk to each other on. We specified external network as a public network so that we can see the outside world and that containers can get DHCP addresses that they can be reached from the outside world. And then this container network capability means that we can actually expose vSphere port groups directly to Docker so that you can attach workloads directly to these port groups. So we're exposing our external network as a container network. Now, when it comes to storage, the question of where we store our Docker images, well, that's going to be here on this iSCSI drive. Where we store our volumes, we can specify multiple volume stores, each of which will have an alias, and this is the only volume store we're going to use here. Vic machine will automatically generate certificates to allow for secure TLS authentication between the Docker client and the Docker endpoint, and it makes that really easy. That's going to be part of the demo, and this is the only thing I have to specify in order to get that. Then down here we actually have our vCenter credentials. So what do we have? We have the address of the vCenter itself and the data center. Then we have the thumbprint of this vCenter, which is an extra security feature. We have the admin user ID, which we don't actually have the admin password. It's set up so that you have to enter the admin password. You can add it in plain text in here if you want to. Most people are not going to want to do that. And then the VCH user. Remember we mentioned as a proxy user that the virtual container host uses when it's installed. So let's exit out of that and let's actually run this. So we use a script to run it called Vic machine, and we're going to do the version. Let's just run it without any parameters. It'll tell us Vic machine version 1.1.0. Then I want VCH3, so it's going to consume that manifest, and then I'm going to say create. So it's going to ask me for the password, and now it's going away and it's going to figure out whether everything is properly configured in order to install this virtual container host, which it's doing right now. So if we actually go back to our vSphere, we should now, if we go to hosts and clusters, we should now see this virtual container host installing. And there it is. You see devcert, that was what we called it. And this VM here is running the endpoint, the Docker compatible endpoint that we will connect our client to. So this is finished. So of all of this information, the most important thing are these environment variables, because that tells us how to connect to that Docker endpoint from a Docker client. So if I do export and then just copy this, the other thing that we need is we need the certificates that were generated here in devcert. So if we do ls, you'll see this is what has been generated. So the user or the tenant needs to have these certificates and these environment variables. And once you have those, if you do docker ps, docker info, we're now connected to vSphere integrated containers. As you can see, the CPU and memory limits that we requested have been applied. So the next question is, as a tenant, what can I now do with this endpoint that you've created for me? So now that the admin has set up this virtual container host for me as a tenant, how do I consume that? Well, I consume it in exactly the same way as I would any other Docker host, using the Docker client, except that this Docker client is talking to vSphere, it's not talking to Linux. So if I do Docker network ls, for example, I see the vSphere networks that I've been pre-authorized to connect workloads to. Do Docker volume create foo, what's that going to do? Well, that's going to create a disk on a data store with the vSphere driver, and I've now sub-allocated some persistent storage on that vSphere data store that I was pre-authorized to use. And if I do docker run -it Debian, for example, what it's going to do is it's going to go away and find the Debian image. Now, in this particular case, it's going to Docker Hub to pull it down. If in most enterprises you would have a local on-prem registry that you would be pulling these dependencies down from, but it doesn't matter. The net effect is the same. It's going to extract these images onto that iSCSI data store that we specified. It's now attached those images as a disk to a VM. It's booting the VM, and in a second it will give me a shell into that VM. There's the shell. So now if I do ls, I'm now in a Debian VM. Now, note I say VM, not container. It's a VM that acts and feels and looks and smells like a container, but it is in fact a VM. And we can see that if we go back to a vSphere and I refresh here, you can see Modest Lovelace. It's running, powered on. If I do ps-ef, you'll see here I'm not in a process namespace. I'm not in a C group. I'm in a VM that's running that container image. If I do, if I type Docker, there is no Docker in here. It's just literally a VM running the container image. But it behaves just like a container in that when I exit, it's just that's going to be stopped. So if I do docker ps-a, you'll see that container is now stopped. It's exited, which means the VM is powered off. You see that VM has powered off. Now, of course, if I do docker rm and a8f, that will delete it. Again, if we look in here, we refresh, see the VM has gone. So we're controlling vSphere infrastructure and VMs, network, and storage from a Docker client. Now, the cool thing about this is that it means I can self-provision anything into a vSphere cluster, provided it's represented as a Docker image. So what else can we do with this? Well, a really cool thing we can do with this is, in fact, spin up Docker hosts using Vic. Now, let me show you what I mean. I have an image that I pulled earlier, which is, again, in my Ben's Doings repository. If you go to dind, Docker in Docker, you'll see a whole bunch of information about how to build these kinds of images, how to use them, ways in which you can. There's far more detail than I want to go into right now, but suffice it to say that I can do docker run -d, and let's do a port mapping, and I can basically do. Let's just take this. There we go. So this is going to run a brand new Docker host as a VM. It's going to map the Docker API to port 10,001. And as soon as it starts up, we should be able to just connect to it and do stuff with it. So now that it's started, let's do docker ps. What I can do now is I can do docker-h and there we go. So that's the host I'm going to be talking to. Now, I made a deliberate mistake here. Now, it's still, my environment variables are still set to talk to the other Docker endpoint. So if I do sudo, it'll ignore those environment variables. Now it's talking to the nested Docker host that I just spun up. So if we do Docker run busybox date, for example, that's going to pull down the busybox image and going to run date in that Docker host. So Docker ps, there it is. Now we could do Docker stop F9E. So that will now cleanly shut down that Docker engine. And then we can do Docker RM, and that's deleted it. So this is basically making a Docker host just as ephemeral and just as easy to spin up and tear down as any other container, which is actually really cool and is the foundation of the Docker Datacenter demo that we put together, which uses exactly this to spin up Docker Datacenter nodes as VMs using Vic. So that's what we're going to see next. So in the previous section, we saw how, as a user or tenant, I can self-provision workloads into vSphere using a Docker client without needing any vSphere credentials. Now we're going to take that now to the next level and install an entire cluster into vSphere, a Docker Datacenter cluster, using all those same techniques. But let's firstly remind ourselves what we're currently connected to. We're connected to a virtual container host that has a certain amount of compute, storage, and networking. Now, as you can see, I have 8 gigabytes of memory, I have 8,000 megahertz of CPU. Let's say I think that's not enough to install Docker Datacenter. So I go back to my admin and say, hey, you know what, I actually would like some higher resource limits. So the admin can just go to the virtual container host, right-click, this is all very normal and natural workflow for them, and say, okay, right, I'm fine, I'm going to double the resource limits. Remember, this is not a resource reservation, this is just a doubling of the limits. So here we can basically select 16 gigabytes. Okay, so I'm going to OK that. Now if we go back to Docker client and do Docker info, you'll see now this has been updated. We actually have significantly higher resource limits. Now the beauty of this is that it's dynamically reconfigurable without any impact to the containers that are running, any impact to the client. We can make these changes whenever we want to. So now that I have some more resource, how am I going to actually start up this Docker Datacenter cluster? Well, let's start from first principles. Now, the way that we scripted this is, in fact, using Docker. So if we do sudo docker run Ben's doings and then ddc cluster create. Okay, the first thing it says is, okay, you need to tell me what Vic endpoint I'm going to install this thing to. So we need to set that as an environment variable. So if we do export to find the Vic endpoint that we've been using, this is the one that we've been using. So let's set that, and we'll set that using -e. Docker host equals that. Okay, fine, it's happy with that. Now it needs to know the path to the certificates for that particular virtual container host, because remember we set up certificate-based authentication, so we need to make sure that it can actually get access to those certificates. So we'll mount those in as a volume. So the volume will be ddc demo vch3 dev cert, and we'll mount that at certs, which is what it just asked us to do. Okay, that's great. So now what it needs is it needs a config file. And let's have a look at the config file that we're going to be using. The config file we're going to be using simply is similar to the VCH config file. It just defines a simple manifest for what this Docker Datacenter cluster is going to look like. So we have the number of swarm nodes, for example, the number of manager nodes, number of worker nodes, how many CPUs, how much memory each node is going to get, which vSphere network each node is going to be connected to, how much persistent storage we should set aside for the image cache on each node. Then the Docker images that are going to form the basis of each node. So remember, we're using that technology we mentioned earlier on, where we start up Docker engines inside of Vic. So everything is originating out of a Docker registry. The images to start up the nodes and all the images that the nodes are then going to run Docker services. So now that we have that config, let's apply the config. So what was it asking us to do? It was basically asking us to mount it by mounting /config as a volume. So we need to mount a separate volume -v ddc demo, and let's mount that to /config, and it should find the config.json file, and it did. Great. So now that it's happy, what's it doing? Well, for a start, it's talking to the VIC endpoint and pulling down these Docker images that we specified in our config. This one basically has it's a CentOS image that has a Docker engine in. It has a Docker EE engine in it, and it has SSHD in it as well, so that we can actually use that to get into a master node to actually run some things. Every other node doesn't have a SSHD in it, and none of these nodes are exposing a remote Docker client. The Docker client is local in each node. So this is going to take it 2 or 3 minutes to set up. So why don't we fast forward to one that's already set up, look at what we can do with it, and then come back to this one. So we're in a different shell now, talking to a different Docker Datacenter cluster that's installed to a different vSphere cluster. Now, the reason that we're doing that is because we have NSXT installed in this vSphere cluster, which I don't have on the other cluster. That's going to allow us to show off the experimental NSX plugin capabilities that we have, that we showed at DockerCon. So let's first look at the vSphere cluster. You see we got 4 hosts here, 4 ESXi hosts, and then a Docker Datacenter cluster deployed into that vSphere cluster. We have a manager that's on IP address 203, a worker that's on IP address 202, and in fact that's this shell here. The manager is here, and the worker is here. There you go, there's the worker. So let's look at the NSX control plane for a second. What do we see? Well, we see a couple of interesting things. We see some firewall rules that have been set up, and we see some switches, some logical switches. Now you see here the containers logical switch. That's actually a switch that the nodes themselves are talking on. And then you'll see one that has a DDC prefix here. Well, let's go and see what that might be. If we, on the master, do Docker plugin ls, you'll see we have the NSX plugin installed. Let's do Docker network ls. Now you'll see here we have a network called PingPongNet that is an NSX network, and that is the logical switch we just saw. So let's create a new one, see if we can create a new logical switch. So let's do Docker network create -d NSX latest, and then let's call it my network. Okay, so if we do Docker network ls, so now for my Docker client, I've now just created a new network in NSXT. Let's go and have a look at that. Let's refresh this. And once it's refreshed, we should see, there we go, a new logical switch has been set up. Now, each of the containers on this logical switch is represented as a logical port. So if I were to create a service, if I do Docker service create -- network, and then my network, and then let's just run something simple like busybox top, that should create a service that's running top in a busybox container, which if we go right to the top here, we should see that. Actually, no, we need to do Docker service ls. Okay, there's my busybox service. If we go back to the NSX control plane, let's have a look at this particular logical switch. Let's look at the ports. You actually see there's 2 ports now. There's the port that was set up initially, but there's the port that's been set up as a result of me running this service. So if I do Docker service rm, and then this ID, so that stopped the service, go back here, and we should see that that logical port should disappear because that service is stopped. And it has. So that's how we tie NSX to these Docker containers. So let's actually look at an example of how we can actually apply firewall rules to this. So let's clear this out. If we do Docker PS, you'll see that we actually have a service called pingpong. And what I'm going to do is I'm actually going to get a shell into this running container, and I'm going to show you what we'll do. So if we do Docker exec -it, and then take that ID, and then bash. Okay, so we're now in that container. If we do ps-ef, you can see what's running in there. There's very little running in there. And if we see the IP address, the IP address that matters for this is 10.0.0.7. Now let's go to the worker and let's look at what containers we have running here. Docker ps, and again I'm going to do the same thing. We have another container running on that same network, and in fact, can we actually see that Docker network, Docker ps? It doesn't actually tell you that it's running on that network. If we were to do Docker inspect and take that container ID, it would tell us that it's running on network ping-pong-net. Yes, the network is called ping-pong-net. All right. So what we're going to do now is we're going to exec into this container too. So if we do docker exec-it, the same thing as we did in the other one, bash. Okay, so we're now into this second container. So they're both talking on the same NSX network. If we do IPAS, we'll see the IP address of this one. This is 10.0.0.5. So if we go into this one here that we were in previously, let's ping it, 10.0.0.5. Okay, so we're now pinging a different container on a different Docker host over an NSX network. So if we now go to NSX and we go to firewall rules, we can actually update this firewall rule. You see we have this this rule here, ping pong 1 to ping pong 2, and it says source 10.0.0.7, destination 10.0.0.5. Now what I can do is I can basically say for the firewall, I can basically say reject. If I say reject and save, we go back to here, you can see now I can't ping this guy. Right now I can't see it at all because I've been able to apply that firewall rule on the NSX network. And if I set it back to allow again and then save, switch back, you should see, yeah, now I can ping again. So the whole point of this is to show that this integration, this tight integration with Docker Engine, is bringing the best of vSphere infrastructure directly to Docker containers. So the last thing I'm going to show you in this particular section is let's actually vMotion this manager. So if we vMotion the manager, let's see what host it's on. It's on host 98. If we actually migrate this to host 79, let's say, we should be good. Just click yes. Okay, fine. Now that's actually going to schedule a live migration of that manager node. Now, of course, this is something that you would likely want to do if you wanted to put one of these ESX hosts into maintenance mode to upgrade it or to do any maintenance to it. The beauty of this is that it's entirely transparent to the client. Now you see that as we went through this vMotion, we're still pinging in the order of milliseconds. There's really absolutely nothing that's interrupted that manager live migration, which has now, or should have now, completed, I think. Yeah, I think that manager is now, yeah, it's on host 79. So now that we've demonstrated the NSX plugin and the live migration, let's go back to our original install. Here we go. So this is the thing we actually set off installing beforehand. Let's see what it's done. It's installed. If we go to our web client, let's refresh it. Okay, it's installed the 3 manager nodes and the 3 worker nodes that we requested in that config.json file. If you remember, if we do config.json, we requested 3 managers and 3 workers. So how do we log into this Docker Datacenter cluster? Oh, by the way, if we do Docker PS, we'll see the nodes as containers in Vic because that's how we deployed them, again, to the specification that we asked for. So how do we actually get into this Docker Datacenter cluster? Oh, before we do that, let's actually look at it. Let's go to the console. So if we go to here, go to the browser, let's actually see our 6 nodes running. Okay, so let's get past this and this. Okay, so admin, the password that I specified. Okay, skip license for now. There we go. There we have our 6 functioning nodes. Excellent, good. So everything has worked. Let's go back to here. Let's actually log in to the master node. So if we, the last line from our install was log into your new Docker Datacenter cluster with SSH-I, and then now when we did the install, it automatically created a key for us to SSH into the one node we can SSH into. So if we do DDC demo VCH3 dev, so this is the directory that has our VIC keys in it, but it also happens to have the key that we created to get into Docker Datacenter. So ID RSA, and then the IP address of the master, which is this. Okay, great, we're in, hooray. So if we do Docker PS and Docker info, okay, we're now inside of our cluster, and we can do Docker service ls to see what services are running. Okay, so we have the UCP agent running on 6 replicas. This is standard Docker data center right now. So let's double check that our plugin, our volume plugin is installed correctly. So Docker plugin ls. Okay, there is the vSphere Docker volume plugin. Now, if you want to find out more about that, you can go to here, github.io/Docker volume vSphere. Suffice to say, it allows you to create disks on vSphere data stores that you can then mount into Docker containers. So we're going to use that as we're going to use Docker Datacenter as an example of how that's really, really useful. So let's do Docker volume ls to begin with. Okay, so we have some local volumes. Let's create a volume on a vSphere shared data store. Docker volume create-d vSphere. Let's call this volume foo. Okay, Docker volume ls. So you see it's created a foo volume on the iSCSI NVMe data store. Now, if you remember, if you go back and look at this, iSCSI NVMe was the data store that we basically selected to install pretty much everything to. We installed all of our Docker Data Center nodes to it. We told it our VCH, that's why we wanted volumes, images. That's basically been our shared data store we've done everything in. So what that means is that every single one of these Docker Data Center nodes can see that shared data store. Every single one of these ESX hosts can see that shared data store. So it doesn't matter what container you're running in what node on what ESXi host, it's always going to be able to see that data store. And that's the value of having this shared volume driver, is it doesn't matter where a service gets provisioned inside this Docker Data Center cluster, it's going to be able to access its persistent storage. So let's show you how that actually works. So if I run, I'm going to create a service. Now I'm going to have to cheat here and actually find the command to create the service. I'm just going to cut and paste that in. So, and you can see why I have to cheat because it's kind of convoluted, but I'm going to create a service called my service. I'm going to mount the foo volume2/data, and I'm going to start Redis. And the reason I'm starting Redis is because it's actually going to write some data to /data, and we'll be able to see that that's happened. Okay, so I've created a Docker service. So I can do Docker service ls. Okay, it hasn't actually started yet, but we've got one replica of that service. And right now, I don't care which node that service is running on. I just don't, because each node can see that volume that I just created. In fact, if we go to the UCP here and we click on volumes, you can actually see that the volume is showing up on all 6 nodes because that's the way it works. So, okay, so now our volume, our service is running. So now that our service is running, it should have written something to /data. So let's just stop that. So Docker volume RM, let's double check that I'm not stopping UCP. No, I'm stopping the right one. No, Docker service RM. Okay. Docker service ls. Okay, so we've stopped that service now. Didn't care what node it was on, but I've stopped it. So now let's run, let's actually peek at that volume. Let's see what's on it. So if we do docker run --rm -it -vfoo data busybox, and that should start up a busybox container with our volume mapped at /data. So if we look at /data, yeah, there it is. So the append-only.aof was actually written by Redis when it started up. So let's exit. Now what we can do is we can restart the service again. Let's restart the service again. Now that service is going to reuse that persistent storage, but again, we don't care what node it's been deployed to in our Docker Datacenter cluster, because we have this shared volume store that's external to all of the nodes. So that's pretty much the end of the demo. We do Docker service ls just to double check that it's running. Yes, it is running. Excellent. So let's just recap what we've seen very quickly. We've seen Vic Engine and all the self-provisioning capabilities that gives you. We've seen Docker Datacenter deployed into vSphere using Vic Engine, and we've now seen the Docker Volume plugin and the Docker NSX Network plugin bring that vSphere infrastructure directly into Docker Datacenter. So I think the final thing we need to do is just clean up. So let me show you how easy it is to clean up. If we just run DDC cluster delete, this is the same scripts. By the way, if you actually want to go and see these Docker Datacenter scripts, you want to go again to my GitHub and click on DDC. You'll see all of the scripts and all the information about how to do what you've just seen, plus all of the details. Okay, so we've now completely deleted that swarm cluster. So Docker PS. Okay, so it's gone. And in fact, if we go to vSphere, we should see that it's gone. It has. Now let's just delete the VCH. If we do vic machine 110 vch3 delete, type in my password, and that's now deleting that virtual container host, and our cluster is completely back to a sane state where nothing exists anymore. So in summary, this is really designed to show the power of not only treating VMs as containers, but the power of combining containers and VMs to get real business value. Thanks for enduring my my fat fingers, and I'll see you again for another demo. Thank you.